Okay, so the live stream is working. Fantastic. That's okay. Well, I think we start and okay. So, Daddy, you wanna do your safety? Okay, 2 more minutes. Because we're fighting against load shedding. It might not even do load shedding. Then we could stay out longer. Bonus. Who's here for the first time? Oh, I like it.
Very exciting event tonight. And before we begin, there's just a few things that I'd like to remind you of. Well, you'll notice that you were given some torches, so that's in case we go out. We expect to go out at around 6. And hopefully, fingers crossed, we won't have to use them. But if we do, I'd like you just to remain calm with the lights on. Use your handy, nifty, awesome little torches, and we'll make our way outside the museum. But also a reminder, we've got 2 exit doors, one to either side. I'm going to flash all the lights now. Well, you're welcome to leave by either one of these doors, so they'll remain open, so that you can make your way out if you need to. And also, please note, this is a no eating or drinking venue. And please remember to wear your masks at all times during the show. And that about sums it up. I'm not going to keep you waiting anymore. We're going to welcome our guest speaker today. And for that reason, I'm on Steve Sherman.
Right, hello everyone, and welcome to this very exciting event. I'm hopefully going to be broadcasting it, just kind of streaming it live on YouTube. For those of you that do not know me, I am involved in space education as well as STEM education, which is science, technology, engineering, and maths. And I've just come from a conference today with the Education Department in math strategy. And of course, our esteemed speaker will be speaking there tomorrow morning on a scientific topic. We'll be talking about how to use mathematics in the space world. But more importantly, Jim Adams is a very good friend of South Africa. He's been a lady once for 15 times. So it's fair to say that he is a friend of South Africa. I really think that he actually likes the place a lot. That's my personal opinion. And he was the former deputy chief technologist for NASA. And that means he was involved in pretty much every single project involving a rocket, involving a electronic or mechanical device traveling to another planet. He was involved in all of it. And he has got some incredible stories, but today he is going to be focusing specifically on the missions to the moon and, of course, thereafter, the missions to Mars. Are there any people who are planning to be the next astronaut to go to Mars? We're going to count the hands. Okay, don't be shy. You are sitting in the right age for that. We're looking forward to it. So, I can give you a whole long CD, but because no kidding is not permitting that, I think we should give Jim Adams a very warm take-out.
Are we on?
A little bit louder.
Let's say 1, 2. There we go. All right, it's good to be back in Cape Town after what is a 3-year hiatus, seemed like forever. The last time I was here, I gave a talk in Johannesburg, science center called Sibona, and the title of the talk was The Journey to Mars. And when I was setting up this lecture series this time around, somebody from Sibona said to me, well, what happened to Mars? Because I wanted to come and talk about the moon. And so that kind of was the genesis of this lecture. It's like, what happened to the Mars? NASA's Artemis program is actually about the moon. So we're going to talk about that connection tonight. If you're hoping to see a lot of pretty starry pictures and that sort of thing, you're going to have to come back to the planetarium sometime and see that. Tonight is really about the journey to Mars through the moon. So we'll talk a little bit about that. The way we have it set up, I have to turn my back to you in order to be able to talk to the slide, so please forgive me. But yeah, so in 2016, this was the vision. NASA would go to Mars in 3 phases. Phase 1 was close to the Earth. Phase 2 would be further out, and then phase 3 we'd actually land on Mars. And it involved all of these different things, commercial enterprise like Elon Musk and SpaceX, and involved Orion, NASA's new space capsule, the Space Launch System, which is getting ready to launch, plus precursors like orbiters and landers on Mars, which a lot of you know about already. But we are now at the stage where we're looking at the moon, and we're talking about the moon. Who can tell me what's wrong with this picture? It's upside down, that's right, because it was taken in the northern hemisphere. There you go. That should look a little familiar. But the region that we want to head to is the southern basin up in this region here, and that's what we're going to talk a little bit about tonight. So somebody said, are we interrupting the journey to Mars in order to be able to go to the moon? And the answer to that is no. The moon is kind of on the way. We'll start by talking about the journey so far. For the last 21 years, Earth has had a permanent presence in space called the International Space Station. People living, working, and finding food, apparently, in space. They have to eat in space. They work in space. I love this picture. He's working too. He's using a thing called a glove box. But if you look at it carefully, he's assembling a Lego kit in space of the International Space Station while he's on the International Space Station. That's kind of fun. Oops. People have to exercise in space. One of the things that not a lot of people know, or maybe they do now, is astronauts in space, in order to counteract the effects of microgravity on their body, have to exercise for 2 hours every day. And most of them end up using this thing called a treadmill. It holds them down and then gives a resistance force as they come on the treadmill. Imagine having to work out for 2 hours every day. So that was phase one. It's not over, but it certainly is what we've been doing. We've got people at the International Space Station. We've got, I can't see the buttons on this thing. International Space Station, and now the International Space Station has been extended through 2030, which is really fantastic news. The U.S. Congress has allotted the funds, and our partner nations have agreed to continue to support the International Space Station through 2030. But more importantly, is the development of this thing called the commercial sector. There are commercial companies like the SpaceX, like Blue Origin, like Orbital ATK, and Boeing that have all decided that they're going to go to space too. And they are going to start generating their own mini space stations in space. These things would be for specific purposes, maybe for manufacturing things in space that you can't manufacture on Earth. Or it might be hotels. You know, you could maybe sell a holiday in space. You run up there and spend a weekend orbiting the Earth in a mini hotel. Could be just about anything. But the neat thing about that is, because of what we've done in the International Space Station, we now have the technology and the knowledge to be able to do such things. And so it's going to be a fantastic decade of space exploration in low Earth orbit. So now we get to phase two, which was back in 2017, considered the proving ground. And what that would mean is we would send missions out between the Earth and the Moon, some destination probably close to the Moon that would enable us to live and work in space, but further away, like we had worked at the International Space Station, but with a further distance, becoming that just more independent. At the International Space Station, if there's a problem, the crew can hop in their capsules and they can be home in a matter of hours. At the cis lunar space, that region between us and the Moon, or at the Moon, it's a matter of days before they can. So would give us a sense of how we become that much more independent. So in order to do that, NASA and 16 nations have gotten together and signed something called the Artemis Accords. The Artemis Accords are really a series of principles of how these nations are going to play nice together in order to go further out beyond the International Space Station, to the moon, and hopefully beyond to Mars. They create governances so that we understand how particular laws apply, but they also explain behaviors of nations and people while we're working together to explore the moon and onto Mars. One of the things that I find really important is protecting heritage. I was at a conference in Europe in Padua 2007, and Google had just announced their prize called the Google Lunar X Prize. And the idea was the organization that could send a rover to the moon and take some pictures first would win $1 million, or maybe it was 30 million. It was $30 million. So the pictures that some people wanted to take were of Neil Armstrong's first footprint on the surface of the moon. Well, at NASA, we thought that was a little risky. I can imagine a rover rolling up and getting out of control to try and get the right shot and rolling right over the footprint. So this idea of heritage, the sites where Apollo landed and other important sites, like the Russian sites, are important for historical reasons. And so one of the things that the Artemis Accords does is set boundaries for that sort of thing. As well as another thing that it does is it talks about orbital debris and how we're going to properly dispose of spacecraft because it's getting a little crowded. And you can see as we go through these, there is going to be a lot of stuff sent to them. This is a little hard for me to see. I have to turn around this way, but there are spacecraft that are already in the moon, like the LRO and Themis. But then we're going to send Pathfinder missions, and we're going to send a thing called a capsule mission, as well as a gateway. This is a little mini space station around the moon. So we go from the International Space Station onto the moon. And people would live and work on this gateway. And hopefully it will become a dropping off point for missions that would go on to the surface. You also see Artemis 2, which that's planned to have crews. But Artemis 1, right up here, which will launch later this year, is going to go to the moon without people. So an entirely human-rated mission, but without people. And so one of the things they've done, we can talk about this a little bit more later, but they've instrumented a set of mannequins to simulate the human body, and so that we can begin to understand what the launch does to the human body and exposure to radiation and that sort of thing. So we won't have actual humans on board, but we'll have simulated humans. In addition, commercial enterprises got involved, and NASA has let out a series of contracts called the Commercial Lunar Payload Service, CLPS. And all of these organizations have signed up to carry small landers to the surface of the moon to various places, not just to carry payloads for NASA, but for commercial enterprise as well. There are people that want to do things like send their ashes to the moon, right? Seems a little odd, but that's what they want to do. There are other scientific organizations that want to understand how the moon quakes. You know, we get earthquakes on the Earth. We also get moonquakes on the moon. And then ultimately, NASA is going to want supplies delivered in advance to the surface of the moon. So turning to commercial enterprise to be able to do that instead of NASA having to do it itself is really important. It's the next step forward in humanity moving further out into space. And so just to give you a sense of scale, you've heard of the Elon Musk's Falcon 9. This is the Falcon Heavy. And then this is the space launch system that we're getting ready to launch later this year. And ultimately, there'll be an improvement to that that will tower even further. Both Big Ben and the Statue of Liberty are not rockets. This is the space launch system. It's already been rolled out to the pad once. They've done a wet dress rehearsal, which means that they loaded fuel into it, learned their lessons. There were some problems. So they're fixing the problem, they rolled it back into the vehicle assembly building, and they're fixing the problems. And then later this year, they'll go on to the moon. The spaceship has been built. It's called Orion. It can carry up to 8 astronauts and has a command structure in the back that's supplied by the European Space Agency. So together, between the United States and Europe, we have this spaceship that's capable of going to the moon, and for people living in it, actually for days at a time, if necessary. Put all that together. So there's the European command module, there's the Orion capsule, covering that goes over top of the fairing, protecting from the wind as it rises up through the atmosphere. This is an emergency escape rocket. Hopefully we won't have to use that. And then put all of that on top of this enormous rocket, and we'll take off. But we don't go to the moon just
Is the light on?
I think we've lost our.
Load shedding and batteries.
Yeah, the mic was load shedded early. So we don't go to the moon just to go there. There are reasons that we're going to go to the moon. Some of them are science. So I'm going to talk a little bit about the science today. There's a theory that our moon was formed early on in the formation of the Earth, but another planetesimal, almost planet, collided with the Earth, created a bunch of debris, and then out of that collision, the moon was formed. We want to try to understand that, and it helps us understand the formation of the Earth. It turns out that we all have a magnetic field. The moon today doesn't have a magnetic field, but there is believed that early on the moon did have a magnetic field. Well, what happened to it? We'd like to know that. It turns out also that that magnetic field gets interacted with the sun. So over time, the sun's intensity has crossed a little bit, and we're in a period where the sun is releasing intensities, sunspots are represented. They are sources of magnetic field, but those magnetic fields interact with our magnetic field. So it's early on. Also has that connected to the Earth. That means that we shielded from the solar winds that would be coming in inside. Right? The magnetic field deflects the particles. Sometimes particles get spiral down the solar. And that's what makes the northern and the southern lights. The particles come in and interact with the atmosphere. The other thing that the connection of the field does is that some of the trees from the Earth, the one that the Earth is still forming, made its way over the magnetic field onto the moon. means that there's portions of the moon, there's portions of the Earth on the moon that we can sample today. About the South Pole. We talked earlier that we were going to go to the South Pole of the moon. Why? Well, blue dots. That, our pole of the moon is right here. We call it the Shackleton crater. And these spots happen to be what we call permanently shadowed regions. Permanently shadowed regions are some of the coldest spots in the entire solar system because we never see the sun, and there's no internal heating from the moon. So, what that does is collect moisture. Thank you. Testing, okay. Yeah, that collects moisture. So, on a winter's day, have you ever noticed how on the glass on the windows, sometimes the steam from a shower or from a kitchen collects on your window? That's because the water moisture wants to go to the coldest spot of the room. The same is true on the moon. So over time, the water moisture that was being transferred, recall, because of that collision between that planetesimal Theia and the Earth, traveled along the magnetic field lines, got to the moon, and then collected in these cold traps, these permanently shadowed regions. Why is that? Well, for one thing, there's water there. This is the spectrograph. The blue shows where hydrogen is. We use hydrogen as a proxy for finding water because water is made up of H2O. So there's two molecules of hydrogen. And the presumption is that where you find hydrogen, you will find water. So far, we've been right on Mars, and we believe we'll be right on the moon. Well, that means that there's a lot of water in Shackleton crater and Jupiter. Getting to it will be hard because it's very, very cold. So we'll have to build a robot that can withstand the cold to try and mine them. But over time, yes, over time, what's happened is layer upon layer has built up in these permanently shadowed regions. And it's been mixed up a little bit because it's been hit by meteorites, that sort of thing. But for the most part, if we could create an ice core, that we get a history of our solar system just by looking at the water ices that are located in these shadow regions. Trying to understand the history of our solar system helps us understand what might happen to us in the future. Which is another reason for wanting to go to the moon and do that kind of stuff. And so, the answer to the question, what happened to Mars? And at Mars, we need all of these kinds of technologies and capabilities and science questions answered. Artemis is the first stop on the journey to Mars. It is taking us from low Earth orbit, where the International Space Station is, out to the moon, where we will live and work and develop further capabilities to go on to Mars. And that's phase 3 that we talked about earlier. So we'll have science missions. Actually, we still have science missions on Mars. We can demonstrate active ascent and landing. We know how to conduct robotic ground trips. We just haven't done it quite yet. And ultimately, in the 2030s, we'll send humans first through to Mars. Now, if you haven't seen this video, it's a little old. It's from 2012. It's how to land on Mars. I'd like for you to watch it from the perspective of this is how complicated it is to put 1 ton of stuff on the surface of Mars. 1 ton of stuff being the Curiosity rover. We just recently did it again with Planetarium, but this was the video release that we were getting ready in 2012 to that Curiosity. Sally, if you would in that video.
when people look at it, so it's good. The top of the atmosphere, down to the surface, takes us 7 minutes. It takes 14 minutes or so for the signal of the spacecraft to make it to Earth. That's how far Mars is away. So when we first get work, we touch the top of the Entering the second landing, also known as referred to as 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0. Any one so the radar ascertains just the right altitude and velocity evidence, just the right time for the rest of the landing sequence. This big, huge airship, yeah, it only slows down to about 200 miles an hour. That's not slow enough to land. So we have no choice, but we got to cut it off and come down. Once we turn those rocket motors on, we understand it will smack right back in the parachute. So the first thing we do is really radical fly off, divert it away from the parachute, killing our horizontal velocity and our vertical velocity, get it over, moving straight up and down. So at the surface with this radar, see where we're going to land. Straight down to the bottom of the crater, right beside a 6 kilometer.
And that goes back into if we were to descend impulsively, our engines all the way to the ground, we essentially create this massive dust cloud. That dust cloud would then only land on the road and mechanisms that get instrument. So the way we solve that problem is by using the cycle.
20 meters above the surface. You have to lower the rover below us on a 21 feet. Gently across, honestly, on the surface.
As the rover touches down and is not on the ground, the descent stage gives a collision force with the rover and must cut the drive immediately and fly the descent stage to a safe distance from the rover.
So that's how we land 1 ton of stuff on the surface of Mars. It's a lot of work, a lot of trouble. There's a lot of math involved in it. there's a lot of science. It's estimated isn't going to need 1 ton of stuff to support them. But we're going to need 40 tons of stuff landed on Mars in order to support the first crew that we might send to the planet in the 2030s. So we've got a lot of work to do. And testing that kind of descent and landing at the moon is going to be invaluable as we move on to the much more difficult environment. Then we'll have to learn how to live on the surface. So far, we haven't been living on the surface. We've been living in the International Space Station. So we'll set up a settlement on the moon where people can work by coming and going in and out of the environment. That will be really important for us as we go to Mars. In addition, we'll have to figure out how to eat on Mars, grow our own food. The mission to Mars, minimum, will be 3 years long. So about 8 months to get there, have to wait until the planets align again, and 8 months back. So all told, it'll be just under 3 years. So we'll have to figure out how we make our own food. And then we have to figure out how to get back. So far, we haven't done that yet either. The Apollo missions, we took a rocket with us. And when they were done playing around on the surface of the moon, they got back in their lunar excursion module, and there was a solid rocket motor that lifted them off the surface of the moon. And then they rendezvoused with the command module, and the command module had the fuel to get them home. Well, we don't have that luxury at Mars. And so we're going to have to take a rocket to Mars. One of the things is we would probably, in order to be the most efficient, is probably would take an empty rocket with no fuel in it and land it on the surface of Mars, and then take the water that we find on Mars and convert that to hydrogen and oxygen to fill up the rocket so that the astronauts can take off. Well, we've never done that before. We have one little instrument on the Perseverance rover called Bentley, I think it's called, that has demonstrated that we can take carbon dioxide.
Moxie.
Thank you. Moxie. That's demonstrated we can take carbon dioxide and separate off the oxygen. Well, that's a good first step, but we certainly have not built up the ability to concentrate it and keep it in the quantities that we would need in order to fill up a rocket. So that's one of the going to Mars is actually coming home. And then we need to get back into the spaceship and come back to Earth. When we come back to Earth from the moon before, we've come back to the Earth from the International Space Station, but we've never come back to the Earth from Mars. And so the speeds will be higher, the aspect ratio, the angles of entry will be different, and so we've got to figure that out. So these are all tests that we will begin to conduct as we go further and further out to the moon and beyond with our eyes. It's not a thing the United States is going to do by themselves. Like I said before, there are 16 nations that have signed the Artemis Accords. Hopefully someday South Africa will sign the Artemis Accord, and we'll get the other nations that are reluctant at the moment to do that as well. But it is a global initiative for all mankind, because it's part of humanity's growth and beginning to understand our place in the universe. Thanks, that's all I had to say. And I'd like to thank my sponsors for bringing me here. I'd like to thank you for being such a great audience. We have time for some questions, right, Sally?
Yes.
I don't know what time it is. We've got 10 minutes for
What about 12 minutes?
Good. So, anybody got a question?
And if we do have any questions from our international guests who are on Zoom, they are welcome to ask questions too.
So, just so you know, if you are a kid and you ask a question, I have a present for you.
Oh, I see hands up.
How will I get to Mars? Remember that big orange rocket? Rocket will push the astronauts into space, and they'll go out to the moon, and then they'll join with another rocket, and will then take them onto Mars. That's an awesome question. You know what? How old are you? You're turning 9. You know, you could be one of the people that works on that system. You could. Someday. Yes, I'm going to come back to you. Anybody over here? I see a question right here. Yes. How many astronauts are there? Well, there are hundreds, right, today. But in fact, the first astronauts that go to the moon, there will be 2. So, and one of them will be a woman. So, maybe you'll be the first girl on Mars. Let's hope so. And you? What's the longest somebody's ever stayed on the International Space Station? Good question. 1 year. So can you imagine having to send astronauts into space for 3 years? That's a difficult problem in and of itself. Just the effect it's going to have on the body. So this young lady in the blue, I shifted over to this side of the auditorium. Is there enough water at Mars to be able to float? Well, we think so. And that's actually what Perseverance and Curiosity are looking for right now, is to find out where the water is located. And we think it's under the surface. So I could tell you a quick story at the time. In the 70s, when we sent the Viking landers to the surface of Mars, they landed, and they dug down, and they found nothing but dry, dusty, red soil. And so we put it back down, and we said, well, there's nothing here. There's no life, there's no water. Where you find water, you usually find life. There's nothing. So we continued to explore Mars, but we also mounted missions to other places in the solar system. Well, a few years ago, probably 2007 or so, the Mars Reconnaissance Orbiter was taking high-resolution pictures of that region where the Viking lander had landed. And on one orbit, everything was normal. The next orbit, there was a crater. So Mars had been hit by a small meteorite, maybe the size of a cricket ball, right? And made a little crater about 2 meters across. And inside that crater, just about 6 centimeters down, the layer of ice, right? And what the interesting thing is, that place where that cricket ball meteorite hit was very close to where the Viking landers sat. So if Viking had just dug down 3 centimeters more, we would have had a totally different Mars exploration program. Totally different. All right.
Jim,
Yes.
we have a question here from Holland Middle School in the US. Mr. McNulty, do you want to unmute and then you can ask your question? Oh, I have to unmute you, I think. There we go. Should work.
Very much. Here's our question.
Oh, they sound like
They're in the matrix.
yeah, you sound like you're in the Matrix.
Can you hear us?
It's a little bit garbled, but we're listening.
Maybe they can.
Try again.
I think it's probably better if you just type it in the chat and then we'll answer your question.
Yeah,
Absolutely. We can take care of that. Let me do that right now.
lady in blue. I have my glasses on, so I hope it's a young lady, right? Yeah, good question. So we're not all going to go to Mars, right? A lot of people will say, well, the reason we should go to Mars is because the Earth is climate change, the earth is going to come to an end, and at some point we're going to need a place to go. Well, I don't see it that way. What I see is that we should be trying to figure out how to fix the earth, right? We messed up this planet, we should fix it. And so the purpose for going to Mars is not so much to be able to find a new destination, because Mars won't. Hello. Mars won't support all of us on that planet. We need to fix our own planet. And it's a really great question on today, because today is Earth Day. And so we should be thinking about ways we can clean up our own Earth. Well, let me tell you something. Space exploration is a challenging problem. And when we explore space, we solve these problems, like how to make rocket fuel in space, or how to change trajectories, or how to withstand the rigors of radiation, or even just how you get astronauts to go to sleep at night. And do you know that every one of those problems has an analog or a problem here on Earth that they can help solve? Those are called spin-offs. And the spin-offs are a way that by exploring space, we actually help the Earth today. An example that I really love is, how many of you know what a whale shark is? Yeah, whale shark. They're very docile creatures. They're enormous. They grow to be like 30 meters long, and or maybe 10 meters. Anyway, but they're very big, and they're dark skinned and covered in white dots. Well, there was a marine biologist and one of the Hubble Space Telescope planners that were having lunch one day, and the marine biologist was talking about these whale sharks and trying to figure out how to track them, because you didn't want to tag an animal like that. And so together they figured out that they could use the pointing algorithm from the Hubble Space Telescope. So the software that tells us where and what star the Hubble is pointing at, they can point at a whale shark, and almost without very many changes, they were able to identify a whale shark by the spots on his back, almost like a fingerprint. And so today, we don't have to tag an animal, you just have to take a picture of it and send it to this tracking center in Australia. And we've solved the problem of tracking whale sharks. There's lots of other examples of spin-offs that come from space exploration. And I think that your question is spot on. What's going to happen to the Earth? I think we're going to fix it. That's what I think we're going to do. Yeah.
Grace has a question. She said that she wants to know, have you ever tasted any of the space food that they've taken up into space? I mean, I know that you get in Kennedy Center, they give you space ice cream. I'm not even sure if it's actually the real thing. So,
can we turn the volume down or something? So, thank you. So, yes, I have tasted space food, and it doesn't taste very good. I would also, another story is my father worked on the Apollo program. And one of the things that he did was he helped to invent the packaging that the space food goes into. So he had brought home, when we were 7th graders, he had brought home several samples of these packets of food. And so there was like a beef stroganoff, and there was Tang, if anybody remembers Tang, it's sort of a dehydrated orange juice. And there was a fruit cake, and I think there was a packet of nuts, things like that. Well, he died in 2009. And when we were cleaning out his stuff, we found these packets that he had brought home. We had, as kids, we'd taken them to school for show and tell and that sort of thing. We found these packets, and the plastic they were in was dry and crackling, and most of the packages were compromised. The tang was still in it. The only food that was still good was the fruit cake, which is not something I'm very careful with. American fruit cake, but it's really bad. So anyway, yeah, I've tasted space food, and I think as we get more and more people to go into space, there's going to be opportunities for space chefs. You know, who in here likes to cook? Maybe you could be a chef on the moon or Mars someday. Yeah. Last question.
Last question. Oh,
There's somebody who hasn't asked a question. Yeah, right there, man, blue shirt. Yes, absolutely. Yeah, indeed, sending things into space, you want it to be as light as possible and as strong as possible. And so early on, we would make things out of steel, and that was really inefficient. Soon we switched to aluminum and beryllium. Today, a lot of the things that would have been made out of metal are now made out of composites, like carbon fibers, almost like the fiberglass that you see in boats. And as we move along, continuing to try and find newer and better materials so that it's not just lighter, but they perform well in space. In fact, there was a project that was started by several countries, the US included, called the Materials DNA Project, something that would begin to understand, just like we have started to understand our own DNA, understand materials in a way that you could cook up something in a laboratory, you could dial in the properties that you need and cook it up in the laboratory or 3D print it in a way that has never been done before. And that's yielded a lot of really interesting things. The technical details of I don't have time to go into, but one of the ones that comes to mind is a metal that changes its thermal properties from one end to the other. But you'd say, well, what do I need that for? You need that sort of thing so that as you are holding a mirror, for example, you don't want the thermal expansion and contraction of the material that's holding it to change over time and therefore change the focus. And so we've been able to come up with a way of 3D printing and mount for that out of some of these newer materials that changes from one property at the base to a different property at the mirror. So adjusting the coefficient of thermal expansion to suit our needs. It's a great one. All right, Sally, I think that's it, yeah? We need to be out of here before the load shed comes, yeah?
So unfortunately, we're going to have to finish virtually, but I'd just like to give a big round of applause to Jen
If I could just say, we would like to thank the Planetarium for hosting us. We are so delighted that they've given us the space, and please watch the space because we're going to try and do a lot more now that we know that the internet is working well here. We're going to try and do a lot more, maybe bringing in some special guests from overseas so that you can enjoy them over here in the Planetarium. So please keep in touch with the social media of the Planetarium. Some very exciting things might be coming up very soon. And thank you very much for joining us. And thank you for all our guests who watched the live stream.
This one's good.